Hey guys, this is Mr. Thompson here, and today I'm just going to do a quick segment over how to mix what we've been talking about with gases and volume, temperature, and pressure and all that, and how to incorporate that into our previous unit over stoichiometry. So I'm going to get started by reminding you of something I've already mentioned in these notes, but it bears repeating. At standard temperature and pressure, 1 mole of any gas will occupy 22.4 liters. It doesn't matter what element it is. It doesn't matter if it's a compound. If it's at standard temperature and pressure, 1 mole is 22.4 liters. So that's 1 mole at 273 Kelvin or 0 degrees Celsius at 1 atmosphere. Anything else, volume will be different. Okay, but at standard temperature and pressure, 1 mole is 22.4 liters. So let's take a look at some examples. Let's try to tie this back into what we've seen before. Take a look at this reaction. Just a simple reaction to form water. Question is, how many liters of oxygen gas are needed to fully react with 15.4 liters of hydrogen gas at STP? It's kind of important that we throw that part in there so you know you can use the 22.4 that we just talked about. So if I take a look at this, the very first thing we always do when we're talking about a reaction and we're going to do stoichiometry, we're going to put what we are given over 1. So 15.4 liters of hydrogen gas over 1. I'm immediately going to draw the next one, and I'm going to put my units down at the bottom. So I have the liters of hydrogen gas right here. And then on top, I'm going to convert it from liters to mole because we just learned a very handy calculation or a handy unit. 1 mole is 22.4 liters, so we can put that in right there. Now, we draw another one. We're going to go from moles of hydrogen to moles of oxygen. Put the moles of hydrogen on bottom. Go to our equation. Go to our reaction. It's 2 hydrogen for every 1 oxygen. So we fill that in. Last, the question did say how many liters of oxygen gas, so we're going to convert this oxygen gas right back to liters. We're going to put moles on bottom, liters on top, and again, 1 mole is 22.4 liters. Put this in the calculator. Numbers on top get multiplied, numbers on bottom get divided, and we get 7.7 liters of oxygen gas. Now that example was pretty straightforward. It was pretty simple. Let's take a look at a little bit more complicated one. Again, I'll give you the reaction. I'm going to tell you that it occurs at STP, but this time the question says how many grams of hydrofluoric acid can be produced from 3 liters of fluorine gas. So it starts me out at liters, and it wants me to go to grams. I know that sounds like it may be intimidating, but you're going to be surprised at how simple this actually is, as long as you understood stoichiometry last unit. Okay, so again, start out the same way. Let's put it over 1. Let's draw the next fraction and put the liters down on bottom. And again, at STP, 1 mole of fluorine gas is 22.4 liters. Okay? Now, on the next one, we're going to convert. We're going to go from moles of fluorine gas using our equation to moles of hydrofluoric acid. So fluorine gas, there's no number, so it's 1. Hydrofluoric acid has a 2, so we're going to fill those in as appropriate. Now, finally, rather than go back to liters, the question said how many grams. Well, we look up on our periodic table where to find grams. So we're going to do the same thing. I'm going to move this unit down to the bottom of my next one. I'm converting to grams. Go to your periodic table. 1 hydrogen, 1 fluorine. 1 mole is 20.006 grams. It's no different than what we've done before. Multiply numbers on top, divide by the numbers on bottom, and you get 5.4 grams of hydrofluoric acid. I don't want you to be intimidated by these problems, and I don't want you to freak out about them. We're going to be practicing with them in class. You're going to have the opportunity to ask me questions, but it's very, very similar to what we've already done. I'll see you guys in class.